Welcome back. Let's do a fun little demonstration of the prototype chain. I'm going to create a dragon, and this dragon will have name as the property. Let's call that dragon Tanya. Fire, well, it's a fire-breathing dragon, so obviously that's set to true. And the dragon can also fight. So this fighting dragon will return, let's say, a damage of 5. That's a pretty strong dragon. And you know what? Just to make it more fun, we're going to add a sing method to this object. And we'll say it returns, let's do template strings. I am this.name, the breather of fire. I am Tanya, the breather of fire. That should make sense. Now, if we do dragon.sing, I have a syntax error because I forgot a comma. Let's try that again. I am Tanya, the breather of fire. Nice. And if I do fight here, I also get 5. Perfect. Now, let's say we have another object now. And this object is just a simple lizard. And this lizard, unfortunately, doesn't have much powers. It has a name of Kiki. And then maybe it can also fight, but definitely not as strong as the dragon. So it's only going to give a damage of 1. Not a very strong lizard. Now, if we, let's say, wanted to borrow a method from the dragon object, we've learned how to do that before, right? Remember bind? Well, I can just do something like const sing lizard, and this const lizard, sing lizard, will have the dragon.sing.bind and borrow that method for the lizard object. So let's console.log sing lizard and run this function. Let's see what happens. I run and I get I am Kiki, the breather of fire. Nice. Very, very cool. But let's say this object gets a little bit more complicated. Let's say that the dragon, this time around, well, in order for us to breathe fire, we have to make sure that we have the fire property set to true. So that we can perhaps do if this.fire, which will be true in our case. If that is true, that's when we return our battle cry. So that if I run this now, I get undefined. Unfortunately, the lizard doesn't have fire set to true. And even though we borrow the method, because we don't have the fire ability, it's never going to sing, I am Kiki, the breather of fire. So what can we do here? I mean, we could manually just add the property, but you can see how it might get more and more complicated here, right? What if we had a big object and we want to borrow more than just one method? We want to perhaps inherit a bunch of these properties for the lizard as well, to make it all powerful. And this is where prototypal inheritance comes in. What if we create a prototype chain that says, hey, I want lizard to inherit all these properties and methods from dragon. How can we do this? Well, we can go like this. We can say lizard dot underscore underscore proto underscore underscore. That is, we're creating that chain from lizard all the way up to dragon. All right, let's see if that works. If I do lizard.sing now, and I run, check that out. I am Kiki, the breather of fire. What about the property fire? That means we have fire as well, right? Let's do fire, just the property fire, set to true. How awesome is that? What about fight? If I do fight, and I run this, well, my power is still 1 because I have fight already defined in my lizard object. So what we were able to do here is we were able to inherit through this prototype chain all the properties and methods of the dragon and override anything that we've already declared in our own object. So that is name and fight stay with us. But as soon as we say something like sing, well, the JavaScript engine is going to say, all right, lizard.sing. Hey, lizard, let's sing. And then it's going to look through the properties and say, I don't see sing here. I'm going to go up the prototype chain because we've created that prototype chain up to dragon and see, hey, dragon, do you have sing? And if dragon has sing, then it's going to run it using this code. Now, what happens if we call something other than sing, maybe dance? And if I run, I get, nope, lizard.dance is not a function because we go up the prototype chain. Does dragon have dance? Nope. And then what do we do next? We go up the prototype chain of dragon. What's the prototype chain of dragon? Well, we talked about this, right? The prototype chain of dragon is, let me comment out the dance here, is the original base object. So that hypothetically, I can use whatever methods this base object has. If you remember, our base object, so if I go const object or const dragon equals, for now, an empty object, and I do dragon dot underscore underscore proto underscore underscore, I get this base object. And I have a few properties here. So if I do, let's say, is prototype of, which looks like comes with the base object, I should be able to use this, right? If I do dragon dot is prototype of, and in here I say, hey, another object whose prototype chain is to be checked. So is dragon a prototype of, let's say, lizard? If I run this, yep, dragon is a prototype of lizard. What happens underneath the hood? We tell the JavaScript engine, hey, dragon, run this method. It's going to look in the dragon object, say, I don't see any method called is prototype of here. I'm going to go up the prototype chain to the base object that all objects are created in JavaScript from, including functions and arrays. And it's going to say, hey, do you have is prototype of? The JavaScript engine is going to say, yep, I have is prototype of. Let's give you that functionality. And for us, this functionality is prototype of does exactly what it asks us to. It asks, hey, is dragon a prototype of lizard? That is, does lizard inherit from dragon? Yep, it does. So we get true. If I change this around to lizard, dragon, and I run this, I get false. Because lizard isn't the prototype of dragon. It's the other way around. Now, you may have noticed something interesting here. Let's take a break, and I'll see you in the next video where we'll discuss this further. Bye-bye.